All right, so we were saying here we got 50 multiple choice questions, 16 of them are on chemistry. Okay, and then for unit 2, we have, looks like 10. Okay, so 10 multiple choice questions on biology. And then we have, 11 for physics. And 10 for global systems. That doesn't add up to 50. I miscounted somewhere. It's that in general. It's generally that. Sorry, I was just kind of roughly going through it. Okay, and then in the written response, okay, so in the written response, there are 87 marks, not 87 questions, 87 marks. Okay. "27 of those are chemistry. "20 of them are biology. "21 are physics. "17 are global systems." Okay. What did I say, 27? So significantly more on chemistry. Okay. And that's just the nature of it because there's a lot of problem solving stuff in the chemistry part. So, you know, because I'm going to ask you to balance some equations. Basically, I'm going to ask you to do exactly the same things I asked you to do on the unit exam, just not as many. Okay, so ask you to balance some equations. I'm going to ask you to, you know, predict the products of a reaction, write the reaction out, predict the products, and balance it. Okay? I'm going to ask you to do a couple of mole equation. I'm going to ask you to write out a chemical equation. I'm going to ask you to predict chemical equations, and then I'm going to ask you to do a couple of mole equation calculations. Okay, so basically the same things I asked you to do on the chemistry unit exam. Okay. In biology, I'm going to ask you about, you know, plant transport, cell transport. Okay, the big things that we spent a lot of time on in that unit. Okay, adaptation of plants and cell size and functioning. Okay, those kind of things are the big things in the written response for biology. Okay, for physics, work energy theorem, graphing, acceleration, and conservation of energy. Okay, and for unit 4, same thing I've told you I'm going to ask you on your unit 4 exam. Okay, I'm going to give you a device or structure and ask you how it uses conduction, convection, and radiation to either harness or remove or eliminate solar energy to do a job. Okay, and you'd have to explain that. Okay, climatogram. Okay, I'm asking you to do that on the unit 4 exam. Here's a climatogram. Tell me what biome it belongs with. Explain it. And a heating curve of water problem. Okay. Okay. So looking at chemistry here. Okay. So specifically today, sorry. Yep. Okay, so specifically today with chemistry, okay, what are the things you need to know and be able to do, demonstrate to me, okay, skills you have to have acquired, okay, for your final exam. All right, first thing we talked about, okay, naming compounds. Well, actually, that wasn't the first thing we talked about. We talked about structure of the atom and history of the atom, and there could be a question or two about, protons and neutrons and things like that. Okay, I'm not going to ask you about any like people or places or anything like that. Okay, but naming compounds, you definitely have to be able to name compounds and write their formulas. Because if you can't do that, how are you going to properly write a chemical reaction or even do a mole equation calculation, okay, if you can't write the proper formula or the proper name, okay, for a chemical compound? So being able to name and write the formulas for compounds is one of those essential skills that you have to have mastered, okay, for the final exam. You have lots of worksheets with keys. Okay, if you go back in the stream, remember I posted the keys way back, okay, for those naming worksheets, so you can check those out. So writing formulae for compounds, as we just talked about, definitely have to be able to do that. Okay, and then, okay, lesson 12 is probably the most important lesson in terms of mark value on your final exam. Lesson 12 is where we talked about the 5 types of chemical reactions. Okay, synthesis, decomp, combustion, single replacement, and double replacement. Okay, you definitely need to know those. Okay, I'm going to ask you about them when I ask you to write chemical reactions, and you need to know the reaction types in order to predict the products of a chemical reaction. So definitely go over lesson 12. Okay, maybe watch a couple of podcasts of the quizzes, okay, where we had to do reactions. In fact, that said, one of the best things you can do to prepare for your final exam is to go into PowerSchool, okay, and look up your quiz marks. If there's a quiz you didn't do well on, click on it. Okay? When it opens up, it'll give you the task details. Okay? In those details, there will be 2 links. Okay? One link will say like quiz 5 questions. If you click on that, it'll take you to the PDF that I posted the day before the quiz that has the questions on it. Okay? The other link will say podcast of quiz 5. If you click on that, it takes you to YouTube, and it's a video of me going through the answers, the solutions to that particular quiz. Okay, so you can look it up, try it, okay, and then watch the podcast to see if you did it right. Okay, if you did, good, you learned it, you're good, you can move on. If you didn't get it right, then that's something you should make a note of. Come in and ask me, can I get some help on this, Mr. Coder? I'm still not getting this quiz right. Okay, that's one of the best ways, okay, to do that, because you can look at your mark and know, I didn't do very well on that one. I wonder why. Have I learned that since? Okay, that can tell you a lot. All right, so writing and predicting and balancing reactions. You're going to be asked to do them all. Okay, there's the written response part of your final exam starts out question 1, A, B, C. Here are reactions, balance them. Okay, let's fill in the blanks with numbers. Okay, the next one is writing them. I give you 2 reactions. I write the whole reaction out in words. I ask you to write it out in formula form, balanced with, and identify the type. And then the next question is 2 reactions where I only give you the reactants. You have to predict the products and balance. Okay, that's the first 3 questions on the test. Okay, balancing, writing, predicting reactions. All right, and there's a fair amount of marks. There's 3 marks for the balancing, okay, and then there's 8 marks for the written reaction and 8 marks for the predicted reactions, 4 marks each. All right, and then after that, mole equation. Got to be able to do your mole calculations. All right, we went over 4 ways that I can ask you a mole equation question. I will ask 2 on the final. And we'll probably have time. I'll go over some of them here in a few minutes, okay, just to review how they work. All right, so those things are all in the written response. They are the big ticket items in terms of marks. There's even some stuff on those things in the multiple choice. Okay, like I could have a question that says, which of the following is a synthesis reaction? A, B, C, and D are different chemical reactions. Okay, you have to identify the reaction that fits that type, things like that. Okay. All right, so remember with the mole equation, okay, we've got n equals little m over big M. That formula is on your formula sheet for the final exam, so you don't have to memorize it, but what you do have to know is what does each part stand for. N, number of moles, little m, mass in grams, big M, molar mass, that's the one that we calculate the number, we add the numbers together off the periodic table, right? Avogadro's number. Need to know what it's for. You don't need to memorize the number. I put it on the formula sheet, but you do need to know what you use it for. You use it if you're being asked to calculate the number of particles, or if you are given the number of particles, you can use it to figure out the number of moles. Okay, remember that Avogadro's number is the number of particles in 1 mole. Okay, that's its importance. Okay, there are a number of multiple choice questions about the lab we did on the properties of compounds, okay, where you had those unknown compounds and you had to figure out what they were. Okay, there are a number of multiple choice questions about that. So, you know, things like ionic compounds are generally crystalline solids at room temperature. Their solutions conduct electricity. They're generally quite soluble. Okay, things like that. Molecular compounds are, you know, any state at room temperature, et cetera, et cetera. Will what be on Google Classroom? It's actually very similar to the review sheet I posted the other day. Yeah. Okay. And of course, this will also be on there, right? Okay. All right. So yeah, definitely know the properties of compounds, and there's a number of multiple choice questions about solubility and the polar nature of water. Okay, remember that water is a polar molecule that doesn't share its electrons equally. So one side of it is positive, one side of it is negative. That's what leads to cohesion, adhesion, okay, all of that kind of the hydrogen bonding, that kind of stuff. Okay, so in the written response, obviously, like I said, you got to be able to balance, predict and balance, okay, mole calculations, right? And I already told you that was the stuff that would be in the written response part of that. Okay. So if there's one unit that you should spend more time on than any other, what is it? Chemistry, for a few reasons. Okay. Yes, it ends up that there's more marks in chemistry than anything else, but that's just the nature of how chemistry works. There's actually the second most is physics, and that's just because it's problem solving, and that's just kind of the way it worked out. Okay. But also, it's the one that's furthest away. Okay, it's the one we did the longest time ago, and so we're most likely to have forgotten stuff about. So spend a fair amount of time looking over your chemistry stuff, okay, because it's going to be a big part. Yep. Okay, other things, right? So like we said, naming, okay, remember with naming stuff, okay, ionic compounds have a metal and a non-metal. All right, what would be the name of this material here? Magnesium chloride. Okay, remember, we don't use prefixes in the name of an ionic compound. However, for this molecular compound, which is made up of 2 non-metals, that would be dinitrogen trioxide, right? Okay. What would this stuff be? Nope. Iron 3 oxide, right? Okay. So here's what we have to do with this one, guys. Remember that some metals have more than one possible charge. So we always have to be looking for that when we are writing the name for an ionic compound. Okay. So in order to figure out which Roman numeral this is, and I can just write right now that it's iron oxide. Okay. But I need to figure out what the charge on iron is. It could be 2 or it could be 3. Okay. So right now there are 3 oxygens. Oxygen always has a -2 charge, which means there are 6 negative charges in this compound. Okay, there are 2 irons, and since the compound has to end up electrically neutral, these 2 irons have to give me 6 positive charges, which means each one of them is +3. Right, so then I would write this is iron 3 oxide. if I was making up this final, I would probably test that in a multiple choice question. Oh, wait, I did. So make sure you know how the Roman numeral stuff works. Okay. Okay. Sometimes ionic compounds can have weird things attached to them called polyatomic ions. Okay. What's this stuff called? Sodium carbonate. Okay. Remember, we don't change the ending of the polyatomic ions. We just write them as they appear in that table of complex ions. All right. What would the formula be for lithium nitride? Probably tough if you don't have your periodic table. Okay, so let's just kind of walk through the rules here just as a review. Okay, first thing I do is I write down each part of this with its charge. Lithium is a +1. Nitrogen is a -3. What do I do with those numbers? Swap and drop, right? Okay, so the 3 goes here, the 1 goes there, but we don't write ones. There's my formula, Li3N. Okay, if I have triphosphorus tetrabromide, tri means how many? 3. P, 3. Tetra means how many? 4. Br, 4. There's my formula. Okay, sometimes we get exceptions like this one, magnesium oxide. All right, so if I'm writing this one down, we follow the same rules as before. Magnesium is a +2, oxygen is a -2. When I drop and swap, what happens to the 2's? Yeah, they cancel each other out. I don't write Mg2O2. With an ionic compound, if I can, I reduce it down to its simplest form. These already work out, so it's MgO. Okay, the same would be true if it was like Mg2 something 4. Okay, I would reduce that down to 1 and 2. Okay. All right, and another exception could be if I had a polyatomic ion, or sorry, not a polyatomic, a multivalent metal like copper. Okay? The Roman numeral tells me what about copper? Its charge. That's okay. That's what we have to remember. A very common mistake is to assume that this means there's 2 coppers. It doesn't. Okay, it means the copper has a 2+ charge, and I want to use that when I drop and swap. This is also attached to what? A polyatomic ion. Sulfate is SO4, which also happens to be a -2. All right, so when I drop and swap this, I'm going to get CuSO4. Okay, those 2's cancel each other out. And there's my formula. Okay, so might be worth, reviewing a few of those, okay, when you're at home. Okay, try that one. Similar to the one we just did. Okay, give you a couple seconds to try that one. So for nickel 2 hydroxide, okay, the Roman numeral tells me that nickel has a 2+ charge. Hydroxide is OH, okay, and it's a -1. Right, now here's the thing, with a polyatomic ion, if I have to put a number beside it, what do I have to do with it? Put it in brackets, right? So I'm going to end up with this. NiOH in brackets 2. Okay, that's really important because that means there's 2 hydroxides. If I write it like this, it doesn't mean the same thing. And it's not electrically neutral either. Okay, there's way more negatives here than there are positives. Okay, this means there's 1 nickel, 1 oxygen, and 2 hydrogens, whereas this means there's 1 nickel and 2 hydroxides. Okay, which is different. All right. What kind of reaction is that? It's a synthesis reaction. Okay. If I'm going to balance it, what am I going to have to do? Okay, I'm going to have to add coefficients. Okay, so right now, what's out of balance is the chlorine, right? There's one sodium, but there's two chlorines and only one over here. So I need to put a 2 here because I can't put little numbers in, right, to make sure that my chlorine's balanced. But now that gives me 2 sodiums, so I have to go back over here and put a 2 in front of sodium. Ringing a bell? Okay. Combustion reactions had special balancing rules. Okay, there were 2 of them. The rules were, we need to balance alphabetically and the rule of 2. The rule of 2 being, if there are an even number of carbons, then I start my balancing with a 2. Okay, that was what the rule of 2 is. 2 is an even number, so I'm going to start my balancing with a 2, and then I'm going to balance alphabetically. So 2 times 2 carbons is 4 carbons. So I'm going to go over here and make sure I have 4 carbons. I have 2 times 6 hydrogens, that's 12. So I'm going to go over here and make sure that I have 12 hydrogens. Now I need to balance my oxygens. There are 8 oxygens here, and there are 6 more here for a total of 14. 7 times 2 is 14, and now my reaction is balanced. So combustion reactions are probably the toughest to balance because they have those special rules. They work different than all the others. Okay? We balance all the other reactions by looking for the largest number and starting with it. Okay. Questions on that one? Okay. What kind of reaction is that? That is a double replacement reaction. What should I probably start my balancing with? I could probably pick a couple of things, right? Like I've got 3 sodiums on one side, I got 3 magnesiums on one side. Either one of them is the safe bet to start with. I start with the biggest number and go from there. All right, I'm going to start with magnesium. There's 3 magnesiums here, so I'm going to put 3 here. Okay. When I do that, that gives me 3 oxygens. I'm going to come back over here and make sure I have 3 oxygens. When I do that, how many sodium does that give me? 6. All right, so I'm going to go over here and make sure that I have 6 sodiums. 2 times 3 is 6. How many nitrogen does that give me? 2. Go back over here. I've got 2 here. All right, now everything is balanced. All right, start with the biggest number and then just kind of chain it from there. All right, I changed that one. Now I got to change this one. That makes me have to change this one, and pretty soon you'll be done. Okay. All right, and then we'll look at a mole equation question. Now, you know what? Before we do that, I'm going to, no, we'll do the mole and then we'll do some predicting ones. Okay, so we'll do the first mole equation calculation here. All right, so how many moles of sodium sulfide are in 250 grams? All right, so first thing I want to do is write down the givens the question gave me. Okay, 250 grams is little m because it's mass. Okay, the other thing I can get is molar mass because they told me this stuff is sodium sulfide, but they gave it to me in words, so I need to convert it to formula form. Okay, sodium is a +1, sulfide is a -2, so I'm looking at Na2S, which will be 22.99 times 2 plus 32.07. Yep. All right, so we got 22.99 times 2 plus 32.07. All right, so our molar mass is 78.05 grams per mole. All right, is that ringing a bell? All right, so now I have little m and big M. Question wants to know how many moles. That's N. N equals little m over big M. So I take my 250 grams, I divide it by the number I just calculated, 78.05 grams per mole. And I'm looking at 3.20 moles. All right, so that's the easiest of the mole equation problems because you don't have to manipulate the mole equation. You don't have to use Avogadro's number for that one. Okay, they don't get any easier than that one. Anyone still need it? Yeah. Or actually, we'll just walk through it together. Okay, we're looking for the mass of 11 moles of dinitrogen hexafluoride. All right, so again, we want to write down our givens. They told me N, the number of moles, 11 moles. Okay, and they told me that this stuff is dinitrogen hexafluoride. So, big M, dinitrogen hexafluoride. Okay, remember, this is a molecular compound. I do not reduce that. The prefixes told me those are the numbers I go with. Okay, so fluorine is 19.0. Okay, so we will have 14.01 times 2 plus 19.00 times 6. That will give us our molar mass. All right, so we're looking at 142.02 grams per mole. Looking for little m. Do I have enough information to find it now? Yes, okay, but I will have to manipulate the mole equation. Okay, what do I need to move to get m, little m by itself? Big M. Right now I'm dividing by big M, so follow my rules of algebra, multiply both sides by big M. All right, so my new calculation here will be that the mass will equal 142.02, big M, times the number of moles, 11. All right, so 1,562.22. And that'll be grams. How important are units? Important enough for 1 mark, yep. Hey, if you forget them, you lose it. So don't forget the mark, or the marks, yes, the units that get you the marks, that thing, yeah. Sorry, felt like Justin Trudeau there with his paper box water bottles. Did you guys see that yesterday? He got caught up without having a canned answer, and he did not do it well. Would have thought a drama teacher would have been able to improvise better, but yeah. They asked him what he was doing to reduce his waste and go away, and he's like, well, first we use these not plastic, paper box water container things. Yeah, it was funny. Yeah, that's pretty funny. Oh no, you can watch the actual interview. It's pretty funny. Okay. All right, let's try this one. Okay. So in this one, what's going to be different about this one? Okay, got to find the number of molecules. So in this one, I'll be using Avogadro's number as well as the mole equation. All right, so I'm looking for the number of molecules. Okay, of calcium chloride. That'll help me get big M. Okay, so that'll be 40.08 plus 35.45 times 2, which should be 110.98, I think, grams per mole. Yep. Okay, and they also told me the mass, 175 grams. Okay, if I'm going to find the number of molecules, what do I need to know before that? I need to know the number of moles. Okay, Avogadro's number is the number of molecules in a mole. So I have to know the number of moles in order to use Avogadro's number, right? So the first thing I want to do is find the number of moles. So I'm looking for N. I have enough information to get that because I have little m and big M. So I'll calculate that first. I have 175 grams of this stuff, and 1 mole of it has a mass of 110.98 grams per mole. All right, so 175 divided by 110.98. So we have 1.576 moles. Okay, so that's the number of moles I have. Avogadro's number tells me the number of molecules in 1 mole. What do I do with those two numbers? Multiply them together, right? Okay. So my number of molecules will be N times Av's number. Okay, so down here, okay, we will have 1.577 times 6.02 times 10 to the 23. So a reminder of how you enter that number into your calculator, because that'll be important on your final exam as well. Okay, so I'm going to take my number of moles and I'm going to multiply it by Avogadro's number. So brackets, 6.02, hit the second function button and the comma, so you get the little e, 23, end bracket. Okay, Avogadro's number always has to be enclosed in brackets when you are using it. Otherwise, your calculator will do order of operations and mess things up. Okay. Okay, so we are looking at 9.49 times 10 to the 23 molecules. Okay, so if you're putting yourself in my shoes while I'm making up a final exam, there are 4 ways to ask you a mole equation question. I'm only asking 2. Do you suppose I would ask one that would involve Avogadro's number? Yeah, I would probably ask one that doesn't and one that does. Okay, if I'm, testing things efficiently, and I did. So make sure you know how to use Avogadro's number. Okay. All right, last way to ask a mole equation question. This time I give you the number of molecules and I ask you to tell me their mass. Okay, so that's what I know right now. I know the number of molecules and I calculated the molar mass. If I'm going to find little m, I'm going to have to use the mole equation for that. I already have big M, but I don't have the number of moles. How can I get it? I can use Avogadro's number, right? Avogadro's number is the number of molecules in 1 mole, and I know how many molecules I have. So I take the number of molecules I have, and what do I do with Avogadro's number? I divide by it this time, right? Okay. So to get N, I'm going to take the number of molecules and divide by Av's number. Okay, so that is going to be 2.5 times 10 to the 24 divided by 6.02. 0.02 times 10 to the 23. Okay? And again, really important, okay, that we use our brackets when we're doing this calculation. Right? So we have in brackets 2.5 E24 divided by 6.02 E23. All right, so we're looking at 4.15 moles. Okay, now that I have N and big M, can I find M, little m? Right, so little m is going to be N times big M, so that's our 4.15 that we just calculated, multiplied by our molar mass, 36.46. So we're looking at 151.41 grams. Okay. If that's something that you need to do a fair amount of review of, remember that if you go back in the stream or go to my YouTube channel and go back to when we were doing that stuff, I did 4 questions a day for 4 days. Okay, so there would be 16 solved examples just like what are going to be on your unit exam. Okay, so if you're having trouble with that and you're wanting to just kind of watch and walk through slowly, okay, the problems, the steps to those problems, okay, that would be a way to do it. And you would also have the quizzes we did on the mole equation. We did a few of those, okay, and any other examples we did in class. Okay, or you can pop in, okay, during the posted times, okay, to ask me questions as well. Okay, any other questions from you guys about chemistry? Okay, so remember that yesterday I posted, okay, the final exam review in Google Classroom. Okay, so there's the final exam review thing. Ethan, this is what you were asking about. Okay, it's kind of a typed up version, key points, major concepts, minor concepts. And then there's a final exam review thing that's got questions with the answers. Okay, so that you can check and see if you're doing them right as you go along. Okay, I don't have a practice final exam like I had for some of the other unit exams, but these are all things that will be on there. That was the lab that we did where we had to identify the compounds based on their physical properties. So, you know, we had a blue crystalline solid that conducted electricity and dissolved easily in water and had a pH of 6. So we said it was copper 2 sulfate, right? So that kind of stuff. So go through lesson 4, all of the stuff that is in there. Okay. The way I'll test that, guys, is a multiple choice question. And I would simply in the STEM say, you have an unknown compound with the following properties. And then A, B, C, or D, which one is it? So if it was, you know, copper 2 sulfate, I'd say the same thing I just said to you. Here are the properties of it. It's blue, it's crystalline solid, it conducts electricity in solution. And then the options would be A, carbon dioxide, B, sugar, C, copper 2 sulfate, D, cobalt 2 nitrate, right? And you'd have to pick. All right, so as you can see here, guys, okay, we've got all the stuff. And actually, I think I put the stuff that's in the other document at the end here. So it's actually, if you go to the questions one, it actually has both documents in it. Okay, just got the skills and key concepts and things like that. Okay, you know, there's a climatogram there. So these are all things that used to be on older versions of the final exam. So they're exactly the kind of thing I'm going to ask. I use the same skeleton every year. I just change the muscles, okay, on it. Okay, so it's always the same framework, but I just change the questions a little bit each year. Okay, but I always ask basically the same thing so that from year to year I have a valid comparison, okay, between tests. Okay. All right, you got a few more minutes. I would say maybe work on that for a few minutes.